Welcome to the deep dive. Today, we're tackling a topic that, well, it sparks endless what-ifs time travel. You, our listener, sent this one in, and we've plunged into a pretty fascinating collection of thoughts on it.
Absolutely.
Yeah.
We've got a really rich set of sources here, looking at everything from, the logical knots it ties us in to the very fabric of space-time itself.
Okay, let's try and unpack this then. Our mission today isn't really about blueprints for a time machine, fun as that might be.
Yeah, maybe next time.
It's more about getting our heads around the crazy paradoxes that popping back to the past seems to create, and also the clever ways thinkers have tried to resolve them.
Right. We'll be pulling insights from discussions on things like causal loops, the classic grandfather paradox.
I'd avoid that one.
Definitely not. And whether free will can even exist with time travel, plus some deep dives into the physics of multiple histories.
Okay, so to get started, maybe we should nail down what we even mean by time travel before we get totally lost in all the temporal twists and turns.
Good call. Yeah, definition first.
So from our sources, the core idea seems to be moving to a different point in time than the present. But crucially, without physically traveling through space relative to, like, your local spot.
Yeah, think of it like skipping chapters in a book. Maybe using some kind of device, the classic time machine.
And it's really important to remember, isn't it, that while it's a staple of science fiction and, a subject of serious thought in philosophy and even physics,
It is, yeah.
the ability to actually do this is, well, it's firmly in the realm of theory, not current tech.
Definitely not flipping a switch anytime soon.
Now, here's where it gets really interesting, historically speaking. Humans have been pondering time for, well, ages.
Oh, forever.
Yeah.
Some sources point out the Inca concept of pacha.
Right, that merged space and time into one sort of interconnected idea.
Yeah, fascinating stuff. And if you look back in ancient Greece, you had these opposing views, like Heraclitus seeing time as a constant river, always changing.
Versus Parmenides, who argued for a more timeless, unchanging reality.
Exactly. And that Parmenidean view, where maybe past, present, future are all equally real, it kind of feels like it opens the door, a tiny crack for time travel ideas, doesn't it?
It does seem to. Then you get McTaggart saying time isn't real at all.
Which, throws a major spanner in the works for any kind of time travel.
Definitely complicates things. And in the medieval period, there were these big debates about whether the universe even had a beginning, this temporal finiteism.
So these aren't new questions. Now, shifting to modern physics, Einstein's general relativity does offer some, let's say, intriguing possibilities, at least on paper.
You mean things like wormholes or...
Well, specifically certain extreme warpings of space-time. They're known as closed time-like curves, or CTCs.
Okay.
Theoretically, these could allow a path through time. Gödel's rotating universe model was one of the first to show how this might work mathematically.
But the big caveat is...
The big caveat is whether these kinds of space-time geometries actually exist or if they could ever be created. That's a huge unknown.
Right. And what about the quantum world? That always seems to add another layer of weirdness.
It certainly does. Some interpretations, like one by Greenberger and Sfozel, suggest something interesting. They propose that while the past we observe seems fixed, maybe before our current moment, there's a range of possibilities. And those possibilities only collapsed into a single history once, actions were taken or observations made.
So the past wasn't quite set in stone until we sort of looked back at it, in a way.
That's one way to think about it, yeah. Now, when we talk about traveling to the future, that's different.
More plausible.
Well, our sources connect that much more directly to the real phenomenon of time dilation from relativity.
Like an interstellar.
Sort of, yeah.
Yeah.
If you travel at extremely high speeds or experience very strong gravity, time passes more slowly for you relative to someone stationary. So astronauts, technically, experience a tiny, tiny bit of future time travel already.
Okay, got it. So we have a working definition, a bit of history, some physics background. Now let's dive into the real head-scratchers, the paradoxes.
And we absolutely have to start with the grandfather paradox, right?
It's the classic. You have to. The ultimate conundrum. A time traveler goes back and does something that prevents their own grandfather from meeting their grandmother.
Right. No meeting, no parent for the time traveler.
Which means no time traveler. So how could the time traveler have ever existed to go back in the first place? It's a real logical knot.
It really feels like a logic bomb, doesn't it? If you could just erase your own existence, The whole premise of going back seems to fall apart.
Exactly. It's often used as a key argument against the possibility of past time travel. Now, philosophy offers a few ways to try and untangle this.
Okay, like what?
Well, one straightforward idea, championed by thinkers like Schwartz, is simply that the past is immutable. It's fixed.
Me?
Meaning, if something happened a certain way, it's just logically impossible for it to have happened differently. You can't change it because it already is that way. End of story. That's a clean, logical cut. Seems almost too simple, though. What if you actually get in your time machine and try to change it? You arrive in the past, you're there.
Ah, okay. That's where the Novikov self-consistency principle comes in.
Self-consistency sounds important.
It is. This principle basically suggests the universe has a way of protecting itself from paradoxes. So in the grandfather scenario, maybe your time machine malfunctions right at the crucial moment.
Or you trip over a rug.
Or you trip, or your aim is off, or your grandfather suddenly decides to go to a different pub that night. Something would always happen to prevent the paradoxical outcome.
So the universe just conspires to stop you. The probability of a paradox-creating event is basically zero.
That's the core idea. It's like the universe has a built-in editor ensuring continuity.
Okay, what else?
Another popular way around this, especially in fiction, is the parallel universes, or multiple histories idea.
Branching timelines.
Exactly. So when you go back and say, prevent your grandfather meeting your grandmother, you're not actually changing your past. You're creating a new, separate timeline.
A whole new reality splits off.
Precisely. Your original history remains untouched. Your existence there is safe. The paradox is avoided because the change happens elsewhere.
It solves the logic problem, but wow, the implications. Infinite universes.
It does raise those questions. Then there's Stephen Hawking's idea, his chronology protection conjecture.
Protecting chronology. Sounds like Novikov again.
Similar goal, different mechanism. Hawking suggested that the fundamental laws of physics themselves might actually prevent the formation of those closed time-like curves we mentioned earlier.
Ah, the CTCs.
Right. So maybe physics just makes travel to the past physically impossible in the first place. Physics itself acts as the ultimate bouncer at the door to the past.
So maybe the universe just has a fundamental no time travelers allowed sign built into its laws.
It's a possibility physicists consider seriously. And then we have David Lewis's take, which is quite subtle and interesting. Okay, he argues that a time traveler in the past, well, they might indeed be able to attempt to kill their grandfather. They could line up the shot, pull the trigger, but they will invariably fail. So Lewis says they can try. They have the physical capability in that moment, but they cannot succeed in a way that creates a logical contradiction. It's a sort of can and cannot situation.
Can and cannot. So the intention, the immediate physical ability might be there.
Yes.
But the outcome is ultimately fixed by the logical necessity of avoiding the paradox.
Exactly. Lewis connects this to an idea called composability. Basically, if the past exists in a specific way, including your grandfather surviving, it can't simultaneously exist in a different way, him not surviving.
It all has to fit together consistently.
Right. The very fact that you, the time traveler, exist in your present proves that your grandfather must have lived long enough in your past. The timeline has to be self-consistent, even if it means your actions in the past are constrained in ways you might not expect.
Okay. That's a lot to chew on, just for the grandfather paradox. Let's move to another temporal tangle. Causal loops.
Ah, yes, the snake eating its own tail.
What exactly defines one of those?
So causal loops are sequences of events where basically an event is both the cause and the effect of another event within that same loop. There's this closed chain of cause and effect, but no clear beginning or origin point.
Right. Our sources use that great example, Keller and Nelson's, I think, about Jennifer the tennis player.
Oh, yeah, that's a good one. Can you walk us through it?
Sure. So young Jennifer gets visited by her future self. Future Jennifer tells her she's going to become this amazing tennis player, shares some personal details only Jennifer would know, gives her loads of encouragement.
Okay.
Inspired by this, young Jennifer dedicates herself to tennis, becomes really successful, and then eventually
She travels back in time.
to give her younger self that initial inspiration. So the inspiration for her success came from her future success, which caused the success. It's a loop.
It's perfectly circular. And the big question is, where did the inspiration, the knowledge she'd succeed actually come from originally?
Yeah, it feels like it just appeared out of nowhere. Information generated ex nihilo from nothing.
And that's the core philosophical problem for many thinkers. People like Miller argued that these loops violate the fundamental directionality of time and causality. How can an effect precede its cause in this way?
Others point to maybe energy issues, like the energy needed to sustain such a loop in space-time.
Right, Horwich mentions that.
Mhm.
The physics of actually creating such a loop might be prohibitive,
Oh.
but not everyone thinks they're logically impossible.
Oh.
Well, David Lewis again draws a parallel. He says, look, we accept things like the Big Bang, which seems like an uncaused cause for the entire universe. If that's possible, maybe self-causing loops within time aren't entirely out of the question logically.
Interesting comparison.
And even Hawking, while he was generally against backward time travel because of paradoxes, conceded that causal loops might be logically coherent even if he suspected physics would prevent them from actually forming.
So they might work on paper, logically, but the universe might have physical safeguards against them, like the chronology protection idea again.
That's a common thread, yes.
Yeah.
Physics might just not allow these structures. Now, our sources also bring up the bootstrap paradox here.
Right, the Harry Potter example.
The classic illustration. I'll explain that one.
Yeah, so the idea is someone gets a copy of all the Harry Potter books. They travel back in time to before J.K. Rowling wrote them and just give all the manuscripts.
Okay.
She then gets them published under her name, becomes incredibly famous. The books exist. But where did the story actually originate?
Exactly. Did the time travelers somehow write them? Did Rowling write them? Did they just bootstrap themselves into existence with no true author?
The information loop again? It's a real head-scratcher.
It absolutely is.
Okay. Shifting gears again slightly, let's think about how all this time travel stuff might mess with our concept of free will.
Another naughty one.
If we can go back, and maybe the past is fixed, like in some of those solutions, do our choices even matter? Are we just actors reading a script that's already written?
This is where things get philosophically really complex. The tension, as our sources highlight, is between our feeling of agency, the ability to choose, to do otherwise, and the apparent constraints imposed by a timeline that might already be set in stone.
Right. If the past is unchangeable, could we truly act differently if we were to travel there? It feels like maybe not.
That's the incompatibilist argument, essentially. Free will, often defined as the ability to have done otherwise, seems incompatible with a causally determined past. If everything's already happened, our choices are just playing out a predetermined sequence.
It makes free will feel like an illusion in that context.
It can seem that way, but compatibilism offers a different perspective. It argues that free will, if defined differently, can be compatible with determinism or a fixed past.
How so?
Well, the paper is Free Will Compatible with Lewis's Account of Time Travel, explores this. It suggests defining free will, maybe not as could have done otherwise in an absolute sense, but more as the ability and possibility to act at one's discretion and with one's own intentions.
Acting with your own intentions. Okay. How does that definition hold up against, say, the grandfather paradox scenario where you can't kill grandpa?
Well, remember Lewis's view. He argues time travel is logically possible precisely because those paradox-generating actions are impossible to successfully perform.
Right. You can try, but you'll fail.
Exactly. So you might intend to kill your grandfather. You act on that intention. In that sense, you're acting freely according to this compatibilist definition. You're doing what you want to do. But the universe, or logic itself, ensures you won't succeed in creating a contradiction.
So your will is free in the sense of forming intentions, but the outcome is constrained by logic.
That's the idea. The paper uses those Frankfurt-style examples like the assassin who wants to shoot someone. But unknown to them, there's a backup mechanism that would have forced them to shoot anyway if they hesitated.
Yeah, those thought experiments.
Right. The point is, even if the assassin couldn't have actually done otherwise because of the backup, did they still act freely if they shot purely based on their own decision without the backup ever intervening?
Compatibilists would say yes, I suppose, because their action matched their intention in the moment.
Precisely. It shifts the focus from could have done otherwise to acted according to one's own reasons and desires. Now, the paper also mentions different models of time, single timeline, branching timelines, hypertime.
And how do they affect this?
Well, they have different implications. The paper focuses mainly on the single timeline model, where if you travel to the past, you become part of that already existing history. Your actions were always part of it.
Which feels very deterministic. Where's the wiggle room?
Yeah. This leads to what Sider calls the strange shackles argument. If a time traveler physically can't create a contradiction, like killing their past self or grandfather, what is it that actually stops them? Is it some invisible force field?
Yeah, what are the shackles?
The paper, following Lewis, suggests these aren't physical shackles, they're the shackles of logic. It's simply logically impossible to create a contradiction, just like it's physically impossible for me to will myself to fly right now.
So it's a constraint on what's possible within a consistent reality, not necessarily a complete removal of intentional freedom.
That's the argument. It also brings up this distinction between hard facts and soft facts about the past.
Okay, what's the difference?
Hard facts are things that are definitively settled by past events and their consequences, like, say, Caesar crossing the Rubicon. Soft facts might be facts about the future that are true in the past, like it was true in 1950 that you would exist in 2024.
Okay. So hard facts seem unchangeable. Soft facts.
They seem potentially changeable if future actions, like time travel, could influence them. The principle of the fixity of the hard past says you can't do something that requires a hard fact to have been different.
Makes sense.
The paper analyzes this and leans towards a compatibilist view overall. It suggests that even with the constraints of a single timeline and the impossibility of paradoxes, a meaningful form of free will acting on your intentions might still exist.
So even if the big historical moments are fixed points, maybe we still have freedom in how we navigate between them or how we react.
Well, potentially, yes.
Yeah.
There might still be room for choice and intention within that framework.
Okay. That's a mind bender. Now let's explore another major proposed solution to all these paradoxes. The idea of multiple histories or branching timelines.
Right. This is a really popular concept, especially in sci-fi, partly because it seems to neatly solve so many problems.
How does it work, fundamentally?
The basic idea is that when a time traveler goes back and alters the past, they don't actually change their original timeline. Instead, their action causes reality to split, creating a new, separate timeline or history.
So the original timeline continues unchanged, and a new one branches off with the consequences of the time traveler's actions.
Exactly. This neatly sidesteps the logical contradictions in the original history. The paradox just doesn't arise there.
So in the grandfather paradox,
The grandfather you interact with, the one you might, say, prevent from meeting your grandmother, exists in a different branch than the one you came from. Your own birth in your original timeline remains perfectly consistent and secure.
it cleans things up logically. Are there different ways to model this?
Yes, our sources mention a couple. There's the straightforward branching space-time model where you literally picture reality splitting like the branches of a tree at the point of intervention. There's also a more mathematical approach called the covering space model, which provides another way to represent these multiple, potentially parallel histories.
And how do these multiple history models help with something like the bootstrap paradox, the Harry Potter example?
Well, they could potentially resolve it. Perhaps the information originates in timeline A. Someone travels back from A to create timeline B, giving the books to Rowling in B. Then maybe someone from B travels elsewhere.
So the causal loop gets spread out across different realities, potentially avoiding a single point of paradoxical origin within one timeline.
That's one way it could work, yes. The paper Time Travel Paradoxes and Multiple Histories really digs into this. It even explores more complex ideas within the covering space model, like the possibility of a finite number of histories that you could cycle through.
Finite repeating timelines. Wow, that sounds incredibly complicated.
It is. The idea is you could potentially loop through a limited set of timelines and maybe even return to one you visited before. The paper proposes mathematical conditions using a theoretical framework involving particles changing color on interaction to see how paradoxes might be resolved, even in such cyclic scenarios.
Okay, colors of particles. That's definitely getting deep into theoretical physics territory.
It is. But the main takeaway is that having these separate timelines, whether infinite or potentially finite and cyclic, offers a robust way to maintain logical consistency when time travel introduces changes.
It certainly seems to resolve the paradoxes more intuitively, perhaps, than the single timeline constraints.
For many people, yes. The paper also touches briefly on how we might, theoretically, be able to experimentally distinguish between these multiple history models and single history models, like Novikov's or Hawking's, if time travel ever became a reality.
It sounds like if we ever do manage to build a working time machine, the first thing we'll need is a really good system for keeping track of which timeline branch we're currently on.
Absolutely. Map and compass required. Now, before we wrap this all up, we probably should briefly touch on the physical possibilities, or maybe impossibilities, of time travel, as our sources see it.
Right, grounding it back in physics a bit. It's crucial to remember that even the theoretical possibilities are very, very limited and speculative, isn't it?
Extremely. We're talking about time as the fourth dimension, which general relativity tells us can be bent or warped by gravity. We see this effect near black holes, and to an incredibly tiny degree, even near large masses like mountains.
And also the real observed phenomenon of time dilation time slowing down at very high speeds. That's future travel, essentially.
Correct. Then you get into the much more speculative stuff, theoretical time loops or time portals, perhaps linked to faster-than-light travel or exotic matter.
But, as the sources emphasize, faster-than-light travel itself seems to run headfirst into the fundamental speed limit of the universe, right? Causality issues and all that.
Precisely. It's a major hurdle in standard physics.
Yeah.
We saw mentions of Gödel's rotating universe solution with its CTCs and Gott's cosmic string scenario. These are definitely way out on the fringes of theoretical physics. Very specific, maybe unrealistic conditions needed.
And it's important to distinguish, isn't it, between what the sources call natural time travel, exploiting space-time weirdness, and Wellesian time travel.
Yes, that's a key distinction. Natural time travel would mean finding and using existing, or theoretically possible, warps in space-time geometry, like CTCs or wormholes, if they exist and are traversable. Wellesian time travel is more like H.G. Wells's machine, a device that just powers through time, potentially violating known physics.
And natural time travel, even if possible, sounds incredibly difficult and constrained.
Hugely difficult, likely requiring conditions we can't create or find. And of course, Einstein's famous immensity highlights the immense, likely infinite energy required to accelerate anything with mass to the speed of light, let alone beyond it.
So yeah, the laws of physics seem to put some pretty significant roadblocks in the way of building that DeLorean.
They certainly do, as far as we currently understand them. So, okay, bringing it all back to our present moment, we've explored these major time travel paradoxes, the grandfather, the bootstrap, the implications for free will.
And we've looked at the main proposed solutions. The idea that the timeline corrects itself, like the Novikov principle.
The idea of branching timelines or parallel universes where changes don't create contradictions in the original reality.
And the possibility that physics itself, through something like Hawking's conjecture, might just forbid backward time travel altogether.
Exactly. And it's clear, I think, that even just thinking about time travel forces us to really question our fundamental understanding of time itself, cause and effect, causality, and even our own choices and agency.
Absolutely. It unravels a lot of assumptions.
Precisely. Which kind of leaves us with a final thought for you, our listener. Considering all these intricate paradoxes, these mind-bending solutions, what does our enduring fascination with time travel actually tell us about how we perceive time and causality?
Is it just a captivating intellectual puzzle, a great source for stories?
Or does it perhaps point towards deeper aspects of reality, deeper questions about the nature of time that maybe we haven't yet fully grasped? It's certainly something to contemplate long after this deep dive ends.
Absolutely. Well, thanks for taking this trip through time with us. Until our next exploration, keep those fascinating questions coming.